What is going on, everyone? And in today's episode, we're going to work on a project that is every programmer's fantasy. It's a tool that already exists, but we're going to improve it. So it's a spell checker, you know, that thing in Microsoft Word that puts a red squiggly underline under your last name? No? Just me? I do have a long-ass last name, though. 1 single letter, 4 sets of double letters, and 1 set of triple letters. But we're going to improve on this by creating a tool that gives us suggestions for misspelled words, kind of like how Google does in their search engine. And how maybe if you use this code, you could make something similar to what Google has and, like, make it rain. Alright, let's jump into it. Just like I've done in the past 23 videos, we'll start off by importing the packages we need. The first one is regex, but the last 2 are the bread and butter of this project. SimSpellPy is insanely fast compared to its competitors. It can provide suggestions for misspelled words, and it's quite accurate, although it does have some hiccups. But you might be wondering, how does it work? Well, the basic premise is that in order to come up with a suggestion for a word, there are 4 basic operations you can complete: deletion, transposition, replacement, and insertion. So let's imagine my head is a letter, along with my wallet. Deletion is simply dropping a letter. Transposition means rearranging the letters. Replacement is removing a letter and putting a new letter in its place. Boom. And insertion means adding a new letter. Well, the creator of the SimSpell algorithm discovered that you can recreate all 4 operations entirely through deletion. Basically, you'll have your input word, which is what you type into something like Google, and a dictionary of tens and tens of thousands of words that comes pre-installed with SimSpellPy. It will take your input word and slice it up into different combinations of letters by deleting up to 2 letters at a time from your input word. It will also do the same thing to every other word you have in your dictionary. For example, take the word sun and the word sin. If you delete the middle letter in both words, you're left with SN. This is then stored, so if we find a slice in our input word that is equal to SN, SimSpellPy will assign this a probability of being equal to either sun or sin. In terms of how it's able to figure out what word to use, it compares all possible combinations from the input term using only deletions and then compares it to those dictionary slices. The frequency of those dictionary slices is then calculated, and the term that appears the most is considered to be the most likely suggestion for your misspelled word. And if you're wondering, well, how can you have a 3-letter word and get a suggestion for a 4-letter word by only deleting letters? Well, you can do this by deleting a letter from a 4-letter word in the dictionary, which creates a 3-letter word. Compare that to your input term and then see if it matches. If it does, you now have a suggestion that is longer than your input term. Now you don't have to worry about transposition, insertion, or removal because a simple deletion can get around all of this. Pretty clever. Okay, that was a lot. Let's write some code. So let's set this up. So first we have our input term. We're going to see if we can get a spelling suggestion for this. Then in the SimSpell class, we'll set the max dictionary edit distance equal to 2. This is a good balance between calculating a sufficient number of possible slices while trying to minimize our computation time. If you make this larger, you'll get more suggestions, but it'll take a longer time to do so. Prefix length is the maximum length of your input term that you want to use to create deletion combinations. The idea is that as you use more characters of the word, each marginal character has less predictive power, so you won't gain as much trying to process all combinations for 12 letters as you would for 10 in this hypothetical example. Next, this bit right here locates the dictionary within your computer. It comes pre-installed with SimSpellPy, and it has tens of thousands of words in it. You just have to type the name of the text file exactly like this, and it'll find it in your computer. To actually load the dictionary, you need to call the load dictionary method from SimSpellPy, which is what we're doing right here. Dictionary path is the dictionary that we initialized up above. And setting the term index to 0 specifies the column within the dictionary text file that has the terms. Same idea with count index equaling 1. This is the column that has the frequencies of each word slice in the dictionary. It's located at column position 1. So now that we have our infrastructure set up, we can generate a suggestion using SimSpell. Before I forget, if you haven't done so already, make sure that SimSpellPy is installed. You can do that by going to your terminal like so, and type pip install SimSpellPy. Click enter, and I already have it installed, so it's going to say it's already there, but for everyone else, it'll install correctly, and then you'll be able to use it. So this is how we're going to be able to generate a suggestion. Verbosity.all means we'll look up to the max edit distance of 2 possible deletions. Remember, that's what we set earlier, so if you set it to 3, it would look up to a max distance of 3 deletions. If we were to set this to closest, it would look for the minimum deletion distance. Once again, less results will be shown, but it's computationally faster. So let's change this back to all. And finally, include unknown equals true means that if a suggestion can't be found, then it's going to return our original word. So let's test this out. Okay, now that everything's run, let's just look at this part right here. If we execute this in the console, we get this weird thing with all these numbers and letters right here. So this is what's called a generator. It's a point in memory where the instructions to run the code is stored. And in order to access the results of that code, we have to loop through it. So let's add a little bit of code to what we already have, and then use list comprehension to keep the code nice and tight. So all this is saying is, for each item in SimSpell lookup, we're going to print it to the console and store it in a list. As we can see when we ran this earlier, there's only one item in this list, so we'll only be printing out one thing. So if we run this, we can see we get the suggestion of amazing, and it took 2 deletions to obtain the suggestion, and it has a frequency of 26,630,190. The higher the frequency, the more likely you are to receive that suggestion. Now, in this case, amazing was the only suggestion that we received. Otherwise, we'd have a list of items returned if there were multiple suggestions. So we've covered misspelling one word and getting a suggestion, but what if we have a sentence with multiple typos in it? Well, it turns out SimSpell can do this for us too. Before, we used SimSpell lookup, but now we're going to use SimSpell lookup compound. Let's first write our sentence. So what we wrote says, I went to the amazing Waffle House on the highway. But what we mean to say is, I went to the amazing Waffle House on the highway. We can see we misspelled amazing, waffle, and highway. Let's use SimSpell to help us out here. So we have a variable, top suggestion, that's what we're going to name it. And we're using SimSpell lookup compound. We pass in our sentence right here, and we specify a max edit distance equal to 2. So what about this remaining code with this 0 right here, this star, and this str? Let's start from left to right. Str means we're going to convert the suggestion that we receive into a string, otherwise known as just text. The asterisk means we're going to unpack each of those generators that are generated when we use SimSpell lookup compound. So this thing that we had over here, this is the generator, and this is what we're going to unpack. Unpacking for a generator means we're going to get the results of the code that is stored at this point in memory. It will then unpack that into a list that we created with these brackets. And then at the end, way over here, this 0 in brackets means that we want the item at the 0th index in the list, which is another way of saying we want the first item. The list is ordered in terms of word frequency, with the highest frequency being the most likely suggestion. So by pulling it from index 0, that's exactly what we're going to get. So let's execute this and see what we get. So we can see we have I went to the amazing warehouse on the highway. Not bad, we were able to fix 2 of the 3 problems, but this isn't the most user-friendly way of being able to show that suggestions were made. So to wrap things up, I wrote this bit of code to try and recreate how Google is able to provide search suggestions. So see these numbers and commas right here that appear in our suggestion? Well, comma locks right here will find the indices for those actual commas in our suggestion, and then top suggestion text will extract only the text from our suggestion. Then we write an if statement that looks at each word in the input sentence and compares it to the suggested sentence. If they're equal, well, we only need to print out our original term. However, if they're different, it will then convert our input text and suggested text into lists, like we do right here with this dot split method. Then it will zip it together and check each word against each other. If the words are equal, then we'll append our original word into holding list. Otherwise, we'll append the suggested term, which we see right here. Writing A and B is an easy way to represent this because we wrote for A comma B in this zip statement, and the way Python works is that if you write it like this, A will refer to the first item and B will refer to the second item. All this means right here is that when we append the suggested term to our holding list, we're going to add some asterisks before and after, so we know that that was a suggested term and not our original input term. Finally, we can write did you mean, and then join all of the words in the holding list together. Now we have our original text combined with the suggestions that SimSpell was able to generate. Alright, let's test this out. So we already executed this portion right here. Now we just need to copy this. We'll paste it into our console. And now we can clearly see we had 3 changes occur because we have 3 words with asterisks around them: amazing, were, and highway. Like I mentioned earlier, the only error we have is the suggested term for Weffel. It should have been waffle, but remember we're only going by largest frequency of suggested word, so we shouldn't expect the most accurate results. We're gonna have to do a bit more work if we want the accuracy to go up. Still, not bad at all. This stuff is pretty amazing once you get your hands dirty with it. This was by far the most complicated video I've made, so if you made it through, major kudos to you. There is a ton more we can do to make this a phenomenal tool, the first of which is updating our dictionary to include our input terms. For example, when Weffel was changed to were, well, we can hardcode Weffel to be changed to waffle. This can be extremely useful if you're able to keep track of what people search for, and you notice that waffle is misspelled the exact same way every time. You can use this now to feed your dictionary and improve it over time. That is how you keep your dictionary dynamic and have it constantly evolve, but I'll let you figure that one out. Make sure to like, comment, and subscribe, and I'll see you in the next one.